This is the first ever real image of a black hole, an object once thought to be pure imagination. It was John Michel in the 18th century who first theorized them as dark stars. It wasn't until 1916 that Carl Schwarzschild, using Einstein's new theory of relativity, gave these dark stars a real mathematical form. Then, in 1979, the first simulation of what a black hole might truly look like was rendered by Jean-Pierre Luminet. Our understanding of these cosmic mysteries is still very young, and perhaps that's what makes black holes the strangest, most fascinating objects in the universe. Some of their features are so bizarre that no one would believe they exist, if not for the math and science that prove they do. But today, no equations or sci-fi. We'll just talk about clear ideas and simple pictures. Let's explore a few simple, fascinating ideas about black holes you can actually talk to anyone about. What a black hole really is. Simply put, it's a place where gravity has become so strong that nothing, not even light, can escape. But what is gravity? It's the invisible force that pulls things together. It's what keeps your feet on the ground, makes dropped objects fall, and holds the planets in orbit around the sun. Gravity is everywhere. Imagine space as a giant stretchy fabric sheet. Most objects, like stars or planets, make small dips in that sheet because of their gravity. Now imagine the pull of gravity getting stronger. At one point, it becomes so strong that even light cannot escape from it. And remember, light travels faster than anything else in the universe. That is a black hole. Once you fall in, there's no way back out. Picture it like a river turning into a waterfall. Far upstream, a boat can steer and paddle to safety, but as it gets closer to the edge, the current gets stronger, until finally, there's a point where no matter how hard you row, you're going to fall down. That edge is what scientists call the event horizon, the point where gravity wins completely. Event horizon is what makes a black hole black. Think of the event horizon as the surface or boundary of the black hole, the invisible edge where gravity becomes so strong that nothing can escape, not even light. Outside this boundary, space behaves normally. Light can move freely, and objects can orbit. Hypothetically, if the sun suddenly became a black hole with the same mass, Earth would keep orbiting normally, just in the dark. But the moment something crosses the event horizon, it's gone forever. Let's go back to our river analogy. The water represents space itself. The event horizon is that exact point in the river where the water is rushing so fast that you can't escape the flow, no matter what. And since even light cannot escape, the black hole appears black. But how are black holes formed? Every black hole begins with a star, a dying, massive one. Stars are like cosmic engines. Deep inside, the nuclear reactions release huge amounts of energy which pushes the star outward, balancing against the inward pull of gravity. But eventually, the star runs out of this nuclear fuel and gravity takes over. The star collapses under its own weight, faster and faster, until the entire core is crushed into a single, incredibly dense point. Imagine something the size of our sun squeezed down into a space no bigger than a city. That's how dense it becomes. For smaller stars, this collapse might stop at a neutron star, an extremely dense ball made mostly of neutrons. But for the truly massive ones, gravity just keeps going. It doesn't stop until it forms a black hole. No light, no surface, just an invisible object. But how do scientists detect these invisible objects? The answer is, we see what they do to the things around them. First, near a black hole, you can observe stars moving in strange orbits, spinning faster and faster, as if pulled by something huge that you can't see. That's one big clue. Second, black holes grow by consuming gas and dust from these nearby stars, a process called accretion. This matter falls toward a black hole, heating up and glowing brightly just before disappearing. These glowing disks of matter, called accretion disks, can be seen with X-ray and radio telescopes. This first real image of a black hole, released to the public in 2019, shows the accretion disks around its shadow. If we could see it up close, the accretion disk would look like this. This is because light gets distorted around the black hole's gravitational field, a process called gravitational lensing. Imagine a clear glass marble placed on a printed paper. The print behind the marble gets warped, much like how a black hole's gravity can distort light coming from nearby and background stars and distort or magnify them. Sometimes, that bending makes a single object appear as multiple images, or even a galaxy as a perfect glowing circle, what astronomers call an Einstein ring. And for astronomers, gravitational lensing is like nature's own magnifying glass. It helps them see galaxies billions of light years away. So the next time you look through a marble or a droplet of water and see light bend, remember, the universe does the same thing on a cosmic scale. It's one of the clearest proofs that Einstein's theory of relativity is right, that mass and gravity really do bend the fabric of space and time. Near a black hole, time itself starts to act strange. Einstein showed that gravity and time are connected. The stronger the gravity, the slower time moves. Massive objects bend space-time, and hence the time taken to traverse through 2 points on the space-time fabric increases. We don't notice it much on Earth, but it's real. Clocks on satellites tick slightly faster than clocks on the ground because they're farther from Earth's pull. Now imagine going near a black hole where gravity is millions of times stronger and hence the time would be slowed down infinitely. To someone watching from far away, your clock would seem to slow down. But for you, time would feel completely normal. The deeper you go, the more time stretches. Until near the event horizon, a few seconds for you could mean years, even centuries for someone far away. So, what really is a black hole? It's a place where gravity simply wins. Stay curious, share this video, and subscribe for more.